Good morning, everyone. We're going to start solving square root equations algebraically. So when solving radical equations in general, it's very similar to solving regular equations, but we may need to square, a number or square a certain term in order to isolate x by itself. So the first thing we're going to do is step one is isolate the radical if possible. So move everything away from the square root symbol. We may need to square both sides. Step three is simplify and solve. And then step four is to check for extraneous solutions. And so we are able to do steps one, two, and three. It's very similar to taking the inverse of one side. If you have had Algebra 2 with Miss Martin before, then you know. But if not, we're going to take this step by step and then definitely hone in on step four to check for extraneous solutions. So on extraneous solutions, we were raising both sides of an equation to the same exponent, such as squaring both sides or taking to the power of 3, as we will later. This may result in extraneous solutions. So I'm pretty much rewriting this word here. And these are answers that appear to be solutions, but they're not. So to identify extraneous solutions, we're going to do this by verifying them, by plugging them into the original equation. So when we plug answers into the original equation, if we get a true statement, that it is a solution. But if it's not, then it's an extraneous solution. So it appears to be a solution, but it's not. So we have three different examples that we're going to do. We're actually not going to do example D, so you may go ahead and cross that one off. I'm going to skip that one for now, and it will come up in a different video. But for now, we're going to work with A, B, and C with three different examples, and we're going to check for those extraneous solutions as well. So for letter A, we need to isolate our variable. Notice we have a 4 on the outside, and then we have a 1/3 in the front as well. First thing I want to do is subtract the 4. Now, if you decide you want to get rid of the 3, make sure you do it to every single term if you're going to do that first. So I subtracted 4, so now I have 1/3 times the square root of x plus 4 equals 5 minus 4, which is 1. Then to clear a fraction, remember for fractions, they're like division symbols. It's just a 1 over a number over the other. So if it's really a division symbol, the inverse is to multiply. So to get rid of the 1/3, I'm going to multiply both sides by the denominator. So this 1/3, the 3's will cancel out. I'm left with what's in the numerator, which is 1 times the square root of x plus 4, which just becomes x plus 4, or square root of x plus 4. 1 times 3 is 3. So now we get to step 2. I've isolated the variable. Step 2 says square both sides. And when I square both sides, the goal is to get rid of the square root symbol. Again, just like taking the inverse as we would with multiplying to dividing and adding to subtracting. For the square root, it is squaring both sides. So I'm not squaring the x. I don't get x squared. I'm not squaring the 4. It does not make 16. I'm simply eliminating the symbols. So I just have x plus 4. And then I do square that other side. 3 squared is 9. From there, I'm going to solve for x like normal, one-step equation. When I subtract 4, then I get x equals 5. Now at this point, I should be done, but this is where we have to check for extraneous solutions. So we're going to plug in the 5 into our original equation. So I have 1/3 times the square root of 5 plus 4, then plus 4 equals to 5. We're checking, okay? So now we're going to do our order of operations. 5 plus 4 is 9, so 1/3 times the square root of 9 plus 4. The square root of 9 is 3. Then I have 1/3 times 3. Well, 1/3 times 3 is 1, plus 4. You know where I'm going with this. So 5 equals 5. Now, because these are true on both sides, I get a true statement. That means x equals 5 is a solution, and not an extraneous solution. It is a perfect solution. All All right, so now we're going to go into B. So I have the square root of x, square root of 2x minus 5 equals x minus 10. So I don't have to do step 1 because there's nothing to isolate where my square root symbol is. So I'm moving on to the next step where I have to square both sides. So I have to square here and square here. Well, we know when we square both sides, square root and square cancel each other out. So I'm left with 2x minus 5. But on this opposite side, I have x minus 10 squared. The whole entire term is squared. So this is like saying x times 10 times x minus 10. Sorry, x minus 10 times x minus 10. So I'm actually multiplying two polynomials, or I'm multiplying binomials here, two binomials here. So I can either use the box area model, or I can use the acronym FOIL, which is double distribution. I'm going to use FOIL for double distribution. If you know the perfect sum, the perfect square trinomials rule, you may also use that as well. Okay. So with that, I'm going to use FOIL just to kind of save some room. FOIL means I'm going to multiply the first two terms. So x times x gives me x squared. O is for the outside terms, so x times negative 10 is negative 10x. I is for the inside, so negative 10 times x is also negative 10x. Then I multiply my last two terms, which is negative 10 times negative 10, which is positive 100. Okay. From here, I combine my like terms, so I still have my 2x minus 5 on one side, and then negative 10 plus negative 10 is negative 20. From here, I'm going to move my 2x and my positive 5 over to the right side. So this is kind of like solving quadratics. We need to move everything to one side of the equal sign. Okay, so I'm going to add 5 to my like term and subtract 2x from my like term. So now I have 0, because those of these canceled out, equals x squared minus 22x plus 105. From here, we're going to solve the quadratic equation by factoring. We're going to see if this is factorable. So I'm going to draw the x here. I don't need to draw the box because the a value here is 1. 1 times 105 is 105. And at the bottom, I have negative 22. I'm going to take my calculator and figure out the sum here. So I go to y equals, change my mode to full. So I'm going to do 105, the top number, divided by x. Repeat the same thing in y2, but now I'm going to add plus x on the end of it. I hit second graph. I'm looking for negative 22 in the y2 column to give me my two answers. So negative 7 and negative 15 are my two answers. So this means I have x minus 15 times x minus 7. And if I were to solve for x here, I would get x would equal positive 15 or x would equal positive 7. So now that I've done that, the goal is to check for extraneous solutions. We're going to plug in 15 and we're going to plug in 7 into our original equation. So I'm going to skip a little bit of steps based on the room that I may have. So to check for 15, we're going to check for 15. So we have the square root of 15. If I plug it into my original equation, I'm doing 15 times 2, which is 30. So 30 minus 5 equals 15 minus 10. Okay, we're checking to see if both sides are equal. So from here, I can either type it all the way in or not. I can do the square root of 30 minus 5. I get 5 here. And then 15 minus 10 is also 5. So 15 works because 5 does equal 5. I'm going to put a box around my actual answer here. So x equals 15 is a perfect solution. I'm going to do the same thing with 7. I'm plugging in 7 in for x. So 7 times 2 is 14. Minus 5 equals 7 minus 10. So 14 minus 5, the square root of 14 minus 5 is 3, because we get 9, and the square root of 9 is 3. So on one side I have 3, but on this side I have 7 minus 10, which is negative 3. So as we can see, 3 does not equal negative 3 here, so 7 would not work. I'm going to go ahead and put nope, because that is an extraneous solution. So this 7 is an extraneous solution. So it appears to be 1, but it actually is not. So x equals 15 is the only answer that will work for this. Okay, now we're just going to go on to example C. So C doesn't have any use for step 1, which is to isolate the radical. There's nothing to isolate there. Then it says to square both sides. Well, as you can see, both sides have a square root. So when I square both sides, they actually cancel out. They do not make 25 minus 49. Okay, they do not do that. We're just getting rid of the symbols. They cancel each other out. It's kind of like what was done here. They cancel each other out. It's the inverse. Positive to negative, negative, positive, they cancel out. So the symbols cancel out here, where I'm left with 5x minus 7 equals 3x plus 11. Now I'm back to solving 8th grade math, which is solving with variables on both sides. So I'm going to move the smallest variable, which will help me keep my answer as positive as possible. The smallest variable is 3, so I'm going to subtract it to the other side. So now I have 2x minus 7 equals 11. Then we're going to add 7 to get x by itself. So I have 2x equals 11 plus 7 is 18. And then when I divide both sides by 2, x will equal 9. Now, lucky enough for us, this is the only thing I have to check for, unlike example B, where I had a quadratic equation to check for both. So let's look at x equals 9. We're plugging in 9 into our original equation. So 5 times 9 is 45. Then I have minus 7 equals the other side. 3 times 9 right here is 27 plus 11. So now I'm going to subtract 45 minus 7 is 38. So I have the square root of 38. 27 plus 11 is also 38, and it's still taking the square root. I really don't need to go any further than this because the square root of 38 matches the other square root of 38. So this means I have my true statement, and x equals 9 is a perfect solution. Okay, now we're going to go on to the second part of solving radical equations, which is solving cube root equations algebraically. So to solve cube root, we're using the same technique, but we're going to cube both sides instead of squaring them. So instead of a 2, we're going to use a 3, but it's very much the same steps. So for this piece, we have a 5 in the front. So very much like how we did our first example, we had 1/3. We had to multiply to get rid of the 3. Here, it's kind of like we're multiplying, but to get rid of the 5, we have to divide both sides. Kind of like solving for absolute value. Or if it was parentheses instead of a cube root. So divide both sides by 5. So now the cube root of x minus 1 equals 5. From here, and we have it isolated. So now I'm going to take the cube root of both sides. So when I do that, I now have x minus 1, because they cancel out on this side. 5 cubed is 125. Then if I add 1, x equals 126. And now all I have to excuse me, all I have to do is check for extraneous solutions. Okay, so I'm plugging in 126 into the x spot. So I have 5 And then the cube root of 126 minus 1 is 125. And then I have 25 on the other side. Just remember we are checking, so I plugged it in. Now I'm going to take my calculator because you might be like, okay, how do I plug this in to check my answers? So from here on our TI-84, we're going to type in the 5 because we can just probably do it all at once. So here's the 5 in the front. Now I want the cube root of whatever I'm taking, right? So I take the math button, and on math I see 4. It gives us cube root and whatever we put inside, which also works for graphing as well. Then I can put 125, plug it in, and I have 25. So all of this being multiplied together is 25, which actually matches my right side. So that means x being 126 is a perfect solution. So now let's do the other side. This time I do need to isolate my cube root. So I'm going to subtract 9 to the other side. So now the cube root of 4x minus 1 equals 10 minus 9, which is 1. Now I have it isolated. Now I need to take the cube both sides. So 3 and 3. Well, 1 to the third power is 1. So I'm left with 4x minus 1 equals 1. And now I solve my two-step equation. When I add 1 to the other side, I get 2. And then when I divide by 4, 2 divided by 4 is 1/2. 2 divided by 4 is 1/2. So we're saying if this could be my answer. You can say 1/2 or you can say 0.5. Either is fine. So now let's check to see. Okay, so I'm going to plug in the cube root of 4 times 0.5, or you can say 1/2, minus 1 plus 9, and we're going to check to see if it equals 10. Okay, 4 times 0.5, or half of 4, is 2. So this is 2 minus 1. 2 minus 1 is 1. The cube root of 1 is actually 1, but if you're trying to do this by hand or the long way, again, you can take your calculator, hit that math button, 4, put in a 1, and we do get 1. So 1 plus 9, and we know 1 plus 9 equals 10, so both sides are equal to each other. So that means 1/2 or 0.5 is a perfect solution. And that concludes notes for solving radical equations. On the other side are practice problems, and that will be done during class. Thank you so much for watching my video, and I appreciate you.